The attach command is useful especially for users who are accustomed to programs like SPSS that always assume you're working with a specific data set. Um, you might notice that many advanced R users don't use the attach function very often, at least when referring to data frames, but that doesn't mean it's wrong. It can be quite handy, and I do use it. Um, if you've got multiple data frames, then I suggest avoiding it unless you know what you're doing and you're comfortable with it. So attach just allows me to specify a data frame that I want R to look in for variables whenever I refer to a variable by name, even if that variable is not in the global environment. In fact, only if that variable is not in the global environment. So if I attach empty cars here, then I can refer to MPG directly by name without typing empty cars $ beforehand, and just see the vector of, uh, I guess, average miles per gallon for each of the cars in the data set. I could also refer to the HP horsepower column by name as well. I can detach empty cars if I want, and now it's not attached anymore. I can see that by typing out search. The search function is quite handy for seeing what the search space is. In R, this is where R is going to look for objects that you try to refer to by name. And all of these things that are currently here are some of the sort of default packages that are available in R that contain things like the square root function or the empty cars dataset that are just available every time you load R. Um, there's nothing else here besides the global environment, which is where the new things we create in this session are going to be located for the purpose of R determining where to look for those names. But if I attach, before I attach empty cars again, let's just show you that MPG will now give me an object not found error, just like we were seeing last time when we tested out whether certain variable names were available for use or already referred to something important. So MPG-R does not know what I mean by that right now, even though it's the name of a column in empty cars, because R has no way of knowing I would like for it to look in empty cars to find that name. But if I attach empty cars again, then MPG will work just fine. And if I look at um, the vector of searchable locations, I will now see empty cars as the very first one after the global environment, which will be a handy reminder if I ever need to know where R is looking for the names of things. Most of the time, you are going to want to work with your own data set rather than empty cars. Um, and you can read in a data set using functions like read.table and read.csv. I have some examples of data sets that I'm going to read in with those functions that I've shared with you ahead of time. And if you open them in other software, you will see that they contain the same data, just represented in different ways as a tab separated table, a comma separated table, and an SPSS data file. We're going to read in each of those this session or in future sessions and see that there are ways to successfully read it in so that we end up with exactly the same data frame, no matter how it was represented initially. First, you'll want to tell R where to look for your files. There are several ways to do this. In this workshop, the main way that I'm going to show you is sort of manually doing it using the change dir option in the file menu. So if I go to File, Change dir, then it will allow me to navigate my operating system's file structure and find my the working directory that I want to use, which happens to be the one that I've already set ahead before starting this recording. So you could use that to point to the directory where you have stored the example data files that I've shared with you. It often makes sense to keep all of the files for a particular project in one directory on your computer and use that as the working directory whenever you use R to work on that project. You can also set the working directory using code that you run directly in R. The setwd function allows you to do that. So I've typed it at the console right here to show you. I'm not going to execute the setwd function right now because I already have the working directory where I want it to. It's also good to know about the getwd function, which allows me to just see what my current working directory is. You can see the path to where I keep my materials for this workshop. And the dir function, which allows you to see a list of files that are, well, a vector of files to be specific in our terminology, a vector of files that are available in the current working directory, which you can see are the ones that I have shared to go along with this workshop. For example, if I ran the line of code setwd c:/ASDF, I'm not going to run it. This directory doesn't exist on my computer. That would set the working directory to the folder called ASDF on the C drive in a Windows operating system. Note that I've used a / here. That's because backslashes are special characters in R. So that's the escape character if you're familiar with other programming languages that handle strings. So you can either replace them with / and R will know that those are the separators between folders in the Windows environment for the sake of specifying R paths, or you can double up the backslash every backslash so that R will interpret it as a literal backslash instead of the escape character and refer to the file path that way. Either of these would work fine to set the working directory to the folder called ASDF on my computer. By the way, I've been occasionally using the up and down arrows to cycle through recently run commands. That's a useful thing to know about. If you're working in R and you're at the console, you can press the up arrow to see the last command you ran and perhaps alter it and run it again. And you can continue pressing the up arrow to cycle through previous commands and the down arrow to move forward in time through the more recent commands you ran. So the read.table function and all of its relatives, just like all other R functions that I will talk about, returns an object. It takes arguments, it returns an object. So you will want to have, in the case of reading in a data table, you will always want to have some kind of name ready to accept that object, a variable name that will be used to refer to the output of the function, which will be a data frame. You'll want to choose a name that will be a handy name for you to refer to your data set in the future. So in my first example, I'm going to use data1. I'm going to call read.table, and the first argument is going to be the file name of the table that I want to read in, which is the example tab separated data file that I shared with you. And the second argument is header equals t for true. That's because the default for read.table assumes that there's no header row for variable names. And so I do have a header row, so I would like to use a different value for that argument besides the default. So after I run this line of code, I can print data1 to the console. I'm just going to do that because I happen to know it's a small data frame. You shouldn't be in the habit of printing entire data frames to the console because most of the time it will be more than you want to look at once, or perhaps just overflow. So here's this small data frame that I made as an example for today. It has 4 variables in it. Suppose that these are descriptions of participants and their performance on some task. The variable gender maybe refers to the participant's gender, age refers to their age, race refers to racial or ethnic identity, and score refers to whatever value they got from whatever task is being used in the study. It's not real data. If I had run read.table without the header equals true argument, then it would have defaulted to header equals false, and you can see that this is not what I want. This data frame has 4 variables called v1 through v4, which are the default names are assigned to them. And the first row of data is the names that I wanted those variables to have, those columns of the data frame. So careful about that if using the read.table command. I can do question mark read.table in order to see to see that information. So here, read.table is described and has header equals false listed as its default. So that's helpful if you want to remember what some of the defaults are in a function before you call it. Another way I can read in my data is by using the comma separated version of the data file. So here I'm going to call this one data2 and call the read.table function with a third argument. I still have the file name. I still have header equals true. I've added another argument in between them. The order doesn't matter of separator and header because I'm naming both of them. And here I've specified that separator is going to be the comma character, which is true in the comma separated file. To be clear, the quotation marks here just denote that they contain the character that I intend to specify as the separator, that's this comma. This other comma after that quotation mark is separating off the next argument to the function. So this is an actual control character in R rather than part of the string. I mention that just to because it can be confusing at first for people not familiar with programming to see quote comma like that. But that is intentional. This is the separator character, which is a single comma. The quotes just specify that that comma is what I intend to use as the separator character, and this comma separates off the next argument. And data2 is the same data frame because the comma separated values file contains the same information except separated by commas instead of tabs. I can also use the read.csv function to read that comma separated values file. This one, I don't need to specify any arguments in this case because it defaults to comma as the separator, and it also defaults to header equals true. So data3 looks just like it should. And let's say I wanted to attach one of these frames in order to use it in my example. I might check the search path to see that empty cars is still currently attached from before. So I'm going to run this line of code to detach it. And I'll run search again just to see empty cars is not there anymore. So it will be sensible for me to attach a different data frame that I want R to use as its default when I refer to a variable name. I'll choose data1. All three of them are identical, so it doesn't matter which one I choose in this case. And when I run search again, I can see that data1 is now the first place R is going to look after the global environment if I refer to an object by name and it's not in the global environment. So I can refer to variables in that data frame directly, for example, by calling t.test with two of those variables. This is one argument to t.test. This is a formula again, and the formula specifies the response variable, a tilde, and then the predictor variable. And so here's a t-test of the average scores by participant gender in this fake data set, which if you're assuming you're already familiar with what a t-test looks like, I'm seeing that the t-value is fairly low. It's negative, indicating that the F group is slightly lower than the M group. The p-value is 0.83, so nobody would refer to this as statistically significant, whatever their threshold would be. The degrees of freedom is fractional, 17.808. That's because this is a Welch two-sample t-test. And of course, if you used var.equals true, then you would see the ordinary student's t-test degrees of freedom of your sample size -2. If you're working with multiple data frames simultaneously, you probably want to avoid using attach and just refer to each data frame by name every time you retrieve one or more variables. But in this case, I'm going to leave this one attached for a little while we walk through some other demonstrations. The next function that I'm going to talk about, the LM function, is the basic linear regression function in R, and it can be used for all sorts of things. It's probably my most frequently used statistical function in R, and it probably will be for many of you as well. So this is a very important function to know about. I'm going to just do question mark LM um, in order to take a quick look at the documentation page. Um, and you can explore this at your leisure if you want. Of course, the first argument it takes is a formula, just like with t.test, and so you'll want to get used to the formula specification language in R because it comes up a lot. It has other arguments that we might take a look at over time, like the data argument and the subset argument, which allow us to specify a data frame that we want to retrieve variables from just for this one function call, rather than attaching a data frame in the long term. Like the t-test function, the LM function outputs an object that has attributes, and you can assign this object to a variable name like model.1. And so that's what I'm going to do for this example. Here I'm going to um, run this line of code in a second, and I'm going to assign the output of the LM function to this model.1 variable name. LM takes one argument here, just the formula. I'll show you more arguments later. But I'm going to, instead of printing the output directly like we did with the t-test, I'm going to keep track of it for the future. So you'll see no output at the console this time because instead I stored the output in this variable named model.1. Notice that I used a period in the variable name. That does not mean anything special. If you're used to like Visual Basic, some kinds of languages where the period is a way of controlling objects within other objects, that's not the case here. It's just an arbitrary character that can be used in variable names, and I've chosen to use it here because maybe I would have a model.2 sometimes, although in this demo I'm not going to have one. One thing I can do is just model.1 at the console directly by running this line of code, which is just model.1. And because of course, as talked about last time, everything after the comment character is not executed. Most of the time I'm not going to do that because the information that R gives about this kind of object automatically is usually less than I want to see. So it just tells me the intercept and the slope for age. Most of the time what I actually want is the summary of model 1. So summary is a function that gives you more detailed information about lots of kinds of statistical output. So the summary of model 1 gives me what I would think of as the standard regression table with some extra information before and after it. So here is that standard regression table that you would see in a lot of software when you run a basic linear regression. And this row of the table refers to the intercept, which is negative 0.09. And if you care about that, not significantly different from 0. This row of the table is information about the estimated slope for age, that is the linear relationship between age and whatever score is included in this data set, which is positive 0.19 in this example, and by most interpretations, statistically significantly different from 0, which you could interpret as suggesting that older people have higher scores on whatever this metric is. It can be helpful to call names of statistical output objects sometimes because you might want to know what kinds of components it has so that you can find the one that you want to work with for a moment. And one of those components is residuals. That can be handy. So I can use the $sign just like I do with a data frame to retrieve the residuals that are contained within this model.1 object. So when I run this line of code model1 $sign residuals, I get a vector of the residuals from this regression model, of which there are 20 because the dataset contains 20 complete cases. And I might use those, for example, in plotting some regression diagnostics. Often, I don't mess around with that kind of stuff. Many times when I'm running LM, I just want the summary, and I don't even necessarily want to store the model object for future reference. So then I might run a line of code like this, where I have my LM function with whatever arguments I want, and I put that entire function within the summary function to just print the summary of that function call to the console directly. and get my regression table.